Okay. Hello, everybody. Welcome again. We are here at the second edition of the Space Intersects Internet Workshop. We are very happy to have all the audience that we have so far. We had 400 registration people. So we will be starting just introducing a brief what's the situation we have now in the workshop and what's going to be the agenda. I am Sergi Figueroa, one of the organizers of the workshop. And later on, we will move to the panelists. So let's start a bit. I will give just a high-level overview. So let me share my screen 1 second. Okay, good. So basically, this is the idea. So I wanted to give you an overview of what are the attendance of the workshop. As you can see, again, as we did in the first version, we have a participation or people registered from worldwide. So it's covering a wide spectrum. But it's important also to see the interests of the people that we have gathered. Then also I wanted to share with you the sector and the profile of the audience that we have that we will have in the session. As I said, as you can see here, we see that most of the interests are in the R&D, on service providers, consult firms, and new space industry and startups. So I think that it gives a rough idea of who is mostly interested and what are the main topics that will come out later on into the discussions too. Then, which are the topics of interest that people has exposed on the registration that they are interested the most? So basically, what we can see here, as we were expecting to, is about communication systems. There is also lots of interest on LEO constellations, IoT and 5G, obviously on the integration and what's going to be the future on all these future convergence. Then nanosatellite use cases and business models. And then we have application, service, and ground stations. Obviously, as you all know, this workshop is much more oriented into the communications that we have and the convergence of technologies when deploying new satellites in the LEO orbit. Then, what I will move forward, just will give you an overview very fast of what's going to be the workshop today. Basically, we will have an introduction. I'm starting. I will hand over when I finish to Daniel Marco, which is the General Director from Digital Economy of the Catalan government, that will explain the Catalan strategy in new space. And then Riyad Hartani will give, from Channel Partners, will give an overview of the situation that we have nowadays on this ecosystem. Then, as most of you already know, we have 3 panels. The first one is the telecom and 5G operators intersecting LEO, partnerships and competitive dynamics, which is moderated by Frank Ryle from Channel Partners. As you can see here, we have several representatives from the industry, which will give their overview. Then we have a second workshop. The second workshop is about LEO technology and deployment challenges by Xavier, and it's moderated by Xavier Lobau, which is the head of Future Projects Division from the ESA, European Space Agency. Again, here you can see that we have a very good representative from the industry that I'm pretty sure that we'll get a very good insight, opinions, and discussions about the topic. And the third session that we have is about more getting into the LEO large-scale deployment. So here, what we wanted to listen is opinion from investors, investment funds, and startups, because it's not only to see what we have today, but where we are going to. So what are the new strategies, the new business cases that industries may have on this new LEO scenario and new economy. This panel is being moderated by Monica Roca, and Monica Roca is the Vice President of the Chamber of Commerce of Barcelona, and also the Director of the ISARSAT group. Then we will close the session with together with my colleague, Riyad Hartani, and here we will make an announcement of the creation of a federated new space lab. So just to finish, I want to thank for the collaboration we have received from the ISA, supporting this event, also together from the Chamber of Commerce and from the Mobile World Capital, Barcelona. So now, as I said before, I hand over my presentation, the floor to Daniel Marco, the General Director of Digital Economy from the Catalan government, to present you the new strategy on new space from the Catalan government. Okay, thank you very much. Daniel, the floor is yours.
Thank you very much, Sergi. Hello, everybody. It's on behalf of the government of Catalonia. It's a pleasure to be here sharing with you our strategy on new space. that has been approved just last month, the 27th of October. I am going to share my screen. I hope you are seeing okay. Let's see. It's going. It's not advancing. Right now. This strategy, the new space strategy for Catalonia, it's part of the digital strategy of the government of Catalonia. And during the last 2 years, we have approved different national strategy on digital advanced technologies in 5G, blockchain, artificial intelligence, and just last, that was in October, regarding new space and that is focused more in nanosats or CubeSats. We are seeing from the government of Catalonia that there is a huge opportunity for this space economy, new space economy, regarding the use, development, and exploitation of these nanosats. Our technology that it's much cheaper, that it's also has an integration of digital technologies, use commercial technologies, and at the end provides an environment for startups, companies or regions like Catalonia that can achieve missions and programs in the space that maybe with the old space was not available or affordable for our kind of economy. Also, it's used during the next years, the right moment to deploy this strategy, because here are some numbers about the launch of 3,500 nanosats in the next 5 years that will generate a very huge market, and a market that will be growing year by year. That means that be positioned in this market by companies, by also regions, by labs, or our research and development ecosystem. It's crucial because when the market will be more mature, will be more difficult, and the barriers will be higher. We have used this next year a window of opportunity, and the government of Catalonia wants to use that window. That's why during the last 1.5 years, we have been working with different stakeholders and different experts. Some of them are today in this workshop. I want to thank all of them for the work that they have done elaborating our strategy. And it's a strategy that has 6 fields of action. First, development of the ecosystem. We have already an ecosystem in this field, but it's needed to develop more companies and a better connection with this ecosystem, and the connection with this ecosystem with other international ecosystems. Focus on research and development in different many areas. There's a huge space of action in different many areas, and we will focus more in IoT, 5G communications, and health observation. And the third is the talent, generate the right talent and connect this talent to our ecosystem. Also to provide the better infrastructures, ground stations, infrastructure for test of different parts of the technology. Also living labs for development, technology, and so on. Service adoption, that means how to act as a user of this technology from the different departments of the government, and also how we can increase the use of this the data that is generated by all these technologies from any areas like agriculture, environment, mobility, and so on. And finally, our regulatory framework, create a law and a specific structure and agency that will deploy this strategy. Catalonia has already an ecosystem, I told you. We have strong R&D research centers that are working in telecommunications, aerospace, robotics, Earth observation, and many other areas. Also, we have the incubator of the ESA here in Barcelona, in Castelldefels, where we have a strong relationship with ESA to develop new startups and to new programs in this area, and many different companies. We have identified 30 companies right now that are working in the new space market, or that has technologies very strong related. Also, we have entities like the Chamber of Commerce of Barcelona that has a specific program to collaborate with the government in this area, and many other institutions that works in the dissemination part or in the trainings for different kind of talent that we already have. But one of the focus that we have, the objectives, is to more than double the number of companies in 5 years, multiply by 4 the number of employees that will be in this market, and multiply by 6 the turnover of these companies. This really an emerging environment, and we have conservative objectives, because depending on the movements of this technology, these numbers will be high pass by more, because some of the companies have big expectations about Catalonia to deploy their activity and to be headquarters of international companies in new space. But we have already started. We have already started with a specific mission program with the Institute of Special Studies of Catalonia, that it's a specific bid. It was already open for design, deploy, and launch 2 nanosats. One regarding to IoT, that will provide us a starting platform to test services and technologies in the connection of LEO nanosats with IoT in Catalonia, and the other with health observation services. And this is the first step for a constellation of different nanosats that the government of Catalonia will launch together with the different agents of the ecosystem. This constellation will generate data, will generate a lot of information that will be gathered in a platform that will be open for the different startups and companies, and also will be used by the government itself for many different departments. This will be like the seed for investments in this area, and also the seed for developing new services. We have a strategy that we apply in different technologies, that it's a mission-driven research, a mission-driven innovation. That means that we put the challenges that we have from the government in many areas, and ask for the local ecosystems and international companies to provide the technology to solve this. And in this cooperation, we are also generating also the capabilities of Catalonia for the future. One of the milestones that we have also already started is the creation of the Catalan Space Agency. It's a specific agency that will be the entity managing the deployment of this strategy. Will be also the reference for any company, any agent. Will be promoting R&D, will be promoting incentives for economic incentives for the companies that want to operate in Catalonia and want to develop their activity from Catalonia to the world. We'll manage many relationships, international relationships. We are a little country with a lot of talent and innovation, but we know that it's in this global economy and this global sector, we need to collaborate with many other countries and many other companies or ecosystems. And finally, it was my time. And finally, this agency will coordinate the different infrastructures that will be available for all companies and agents to develop their activity. Thank you very much for being part of this workshop. Thank you very much for being part also of the relationship that we can have from Catalonia to all you. Think in Catalonia when you are thinking about new space, think about the deployment of our strategy, but most of that, think about the agents and the companies that we already have and we want to promote. Thank you very much and have a nice workshop.
Thank you very much, Danny. I think that now we hand over to Riyad. He will give us an overview of the current situation. Riyad?
All right. Thank you very much, Sergi. Let me bring up the slides here. Do you see them?
Yes.
Okay, very good. Yeah. Thank you very much. And I'm Riyad from Zona Partners, and I would like to welcome you to the second workshop related to the low Earth orbit and in a broader sense to non-geostationary orbit constellations. So I was thinking about this workshop this morning. It's 7 in the morning here on the Pacific West Coast time. And I realized that since we had the first workshop late in February, since then, there is about almost 1,000 satellites, LEO satellites launched since then, which tells you about the intensity and the energy going into this area. So there are a number of constellations that are in plans, a number of them that are already launching and doing better services. I think it's really timely. It's really a time where a lot of things is happening, and it's probably a good time to talk about a new era in space internet. We've had multiple phases, but I believe we are in a new era at the moment. And I think it's very important when we do that to realize that this low Earth orbit constellations is really a building block within the overall end-to-end internet delivery value chain. So I think what we're going to be seeing over the next few years and decades, I would think, is really how all these building blocks in the end-to-end delivery of the internet will work with each other. And this applies in particular to this new generation of low Earth orbit and medium Earth orbit constellations. So what does it really mean? I think these are the topics that we're gonna be looking at in this workshop. We're gonna obviously look at the latest developments in LEO and MEO and other satellite technologies, but also address the dynamics that these have with other components and building blocks of the end-to-end internet delivery. I'm listing few of them here, just to illustrate what that really means, and just to open up the stage for discussion that we're going to be having over the next couple of hours. So first is basically the dynamics between LEO, MEO, and the GEO satellites, and I think on that front, a key point is really to see how the dynamics will work out given the different cost structures, the different characteristics in terms of latency and capacity and delivery models. Are they competing? Are they like leveraging each other's? I guess it will depend on the context. It depends on the application, depends on the delivery model, and so on. Similar, we have this new generation of high altitude platforms, from balloons to drones and so on. And I think there is a lot of synergy with the LEO constellations in terms of complementing each other's and specifically unifying the control plane that will be controlling that whole interaction. Then obviously we have the direct interaction between the NGSO constellations and anything mobile, 4G, 5G, but actually also 3G and to some extent 2G in a lot of the world, and specifically part of the world where coverage is limited or there is no coverage. So there, I mean, there is the obvious aspects of like, you know, backhauling, mobile traffic, but then there is a lot of ongoing work in different standard bodies on 3GPP, for example, non-terrestrial, and how 5G would work with this type of constellations. Similar when it comes to Internet of Things, either the 3GPP IoT or the low power wide areas. We have constellations being launched specifically to address the IoT use cases, either via gateways to space or directly end device to space. So we'll see a lot of that as well discussed within the panels. Then we have the dynamics between the NGSO constellations and the wireline access, as well as fixed wireless access. There is a lot of energy going into building and connecting, you know, like businesses or residential via fixed wireless, for example, in either like, you know, the, let's say a 3.5 gigahertz frequencies or the unlicensed higher frequencies in the 60 gigahertz and so on. So how would that work, and how, like, you know, the LEO-MEO will interact with that? Competition, complement, again, the same question. There is the interaction with all this, I would say, initiatives in building private enterprise, private wireless enterprise networks. This is a wave that's going on in a number of regions of the world, mostly because spectrum is being awarded to private enterprises. We see that, like, you know, in a number of regions. And as you do that, basically how to make the business case for these private wireless build-outs would work, and how LEO-MEO will play into that, either as backhaul or complementing the access and so on. So that's another area of high interest. Then there is the, you know, as we build this like global constellations, I mean, the LEO-MEO tends to be global in nature, at least for some of the broadband constellation that scale. Then the question pops up, what does it really mean for submarine networks? I think we, you know, from our studies and analysis, we converge to a direct complement there to extend the reach of submarine networks, to probably act as a backup or as a redundant mode for these submarine networks. So that topic will be addressed in some of the panels as well. And then, like, finally, and this is not exhaustive by any means, I mean, this is just to list some of the interaction models. We have the interaction between all these constellations and the way we build or we architect all these clouds and data centers. There are multiple deployments model as we see global partnerships between the LEO constellations providers and some of the cloud providers, either by building express path from ground station to different types of public or hybrid clouds, or re-architecting the edge cloud, edge data centers architectures to basically deserve content closer to the end users in complementarity with the LEO and MEO and others. So anyway, so there are many other things going on. I think the key point to get out of this story here is basically a couple of key points. I mean, the first one is, yes, we've seen like, you know, a first generation of LEO-MEO, but like 20, 25 years ago and so on. But now, because of all the dynamics in terms of the cost structure of launching satellites, of building satellites, of managing these constellations, as well as the demands, requirements from an end user perspective, residential, businesses, governments, it's sort of like putting a new energy, new emphasis on these constellations. So that's point number one. There's a lot of energy investment, build, rollout. So what does it really mean? So we need to understand that, and we're gonna try to address that. And second, it has to be seen as a building blocks in the end-to-end internet delivery, And I listed some of the interaction with the overall ecosystem here. It's complex, it's fairly recent. There are a lot more questions than answers. There are challenges for sure, technical and business, but there are clear opportunities as well. And I think that's the main goal of this workshop here. So yeah, I welcome you. Thank you very much for joining us. And yeah, I will hand it over to Sergi, and so we can run it from there to introduce the panelists. Thank you very much.
Okay. Thank you very much, Riyad. I think that you gave a very clear overview that will be supported by the following speakers. So just to continue, I don't want to block it anymore. So I will hand over to the next session, which is moderated by Frank Rayal, which is member and co-founder of Chona Partners too. So Frank, the floor is yours.
Hello and good day to all. My name is Frank Rayal, and I would like to welcome you to the first panel of the workshop. On this panel, we will discuss the intersect of NGSOs, the LEO and MEO constellations with the terrestrial networks and explore synergies between these industries, as well as the opportunities and challenges that convergence of terrestrial and space internet bring. We have a terrific representation on this panel, so I would like to introduce the participants, starting first with Jean-Luc Villemain. Jean-Luc is Executive VP of International Networks at Orange. He heads Orange International Networks Infrastructure and Services and is the chairman of the supervisory board of Orange Marine. So Jean-Luc brings the perspective of operating telecom services in both emerging and developed markets. So welcome, Jean-Luc.
Hello.
Next, we have Jakob Krutte. He's Executive Vice President of Products at KPN. Jakob has responsibilities for product management and business implementation of KPN's 5G services. And in his former role at KPN, actually, Jakob was CIO of the fixed service division. So he brings a unique perspective on telecom products and operations. Welcome, Jakob.
Thank you.
We also have with us Artur Mendes. He's Vice President of Sales at Angola Cables, where he leads operator and retail accounts. Just briefly about Angola Cables, it's a submarine cable operator that connects Africa with Europe and Latin America and North America. And they also operate data centers and an IXP. And Artur has been a driving force behind the business growth of Angola Cables. So welcome, Artur.
Thank you. Pleasure.
And last but not least, we have Azhar Sayed. He's the chief architect at Red Hat Cloud. Azhar is responsible for architecting Red Hat open source solutions and services into the network, into telecom networks, into data centers and the telco cloud. So Azhar brings or bridges actually both the cloud and the telco space. And he brings the perspective of a cloud player into this discussion. So welcome, Azhar. Very excited to have you all on this panel.
Thank you.
And to kick things off, maybe what I would like to do is just to give a brief context on the situation, at least how it is evolving. When we look at the two industries, the satellite industry and the terrestrial-based network, we see that they progressed along parallel lines, at some points intersecting where there are extension of services, let's say of terrestrial networks, but often also confrontational, such as when it comes to spectrum rights for satellites and mobile networks. But largely, the two industries have kept apart with distinct interfaces. Now, what's happening with LEO and in NGSOs in general is that we see more convergence between these networks. And what would be interesting to kick this off and to start talking is, what do you see in terms of synergies? If you can just comment at it, basically, I'll go through with all of you, basically, is to comment on the synergies that you see between your part of the business and the emerging NGSOs, the LEO and the MEO. With that, maybe Jean-Luc, if you don't mind, I'll kick it off to you, and you can start us off on this, and then we'll move through it.
Thank you very much, Ray. Hello, everybody. Yes, I think that you're right. It's a key point to say that those two industries, traditional telco on one side and satellite on another one, have different way of work. Okay. If we speak about the future, it's very clear that we will need a complete panel of technology in order to fulfill all the requirements that we will have to satisfy, especially in terms of coverage. We can speak, of course, of a rural area in Europe. We can speak about not fully developed country in Africa and so on. And it's very clear that LEO or any kind of constellation approach using satellite can be very useful. But in order to be able to put in place this kind of complex solution, we need to have a convergence between the way of work of satellite and the way of work of terrestrial. And as a matter of fact, this is not the case today. In a traditional telco, we are used to work with standards, by instance, okay? All our technology are standards, they provide standard interface. We know that we can interconnect one equipment of a supplier with another equipment of another supplier without any problem. If we take the example of the satellite, it is not the case at all. Each satellite has its own modem, they have their own equipment, and you cannot use an equipment from a satellite provider to another satellite provider. That just doesn't work. This is just an example, but that shows at which point the two technologies have different way of work. I really do believe that with Constellation, there is an opportunity, and definitively there are some possibilities. But the question for me is, will the satellite industry will be able to change in a such way that we will be able to integrate them in this kind of solution? Or will they stay on their actual way of work and they will kill, once again, all these new possibilities?
Perfect. Yeah. Jacob, if I may go to you next on that question.
Yeah, absolutely. And thank you, Frank, for the opportunity. I'd like to build a little bit on Jean-Luc's arguments on that. And I come maybe from a bit different perspective, which is some of the companies I'm working with, some of our customers are big shipment companies, etc. And that's one part. The other part is we have wind turbine parks in the North Sea where they want to do a lot of maintenance, inspection by drones, things like that. And they need connectivity. And then they came at us and they said, okay, can you provide us with that connectivity? And we started scratching our head. How are we going to do that? Because we know exactly what's happening on the terrestrial side, but how to do it on offshore, on the sea side. And we're cooperating at the moment in the North Sea with Tampnet, which is a Norwegian company using the oil rigs to build out a network. But that's not enough. So started to get in contact with the European Space Agency and to see whether we could, with that space agency, fill in that particular gap of coverage at sea by using LEO and MEO satellites. So this extra element of the way to cover different areas is really something which is an add-on to our service. And I fully agree with Jean-Luc. what we definitely need to do is, can we build out one standard to make use of the satellite communication part and the terrestrial communication part? Because now it's completely separate and we need to bring it together. And I think that's also one of the subjects that 3GPP is now working on to get it into the 5G standardization process. So I think we're making some baby steps, but we need to put some extra emphasis on that to really serve a lot of extra customers and fill in the holes in rural sites, but also on the ocean side and the sea side.
Okay, Artur, like coming in from the submarine side, one may think of you as being a step removed from the satellite. So how do you rationalize this, or what is the opportunity for a submarine?
I do believe that there are several ones, and you must remember that I'm not only coming from submarine cables, but also from Africa. So if I look to Africa and to the cost of developing terrestrial infrastructure, that is pretty expensive, and the countries itself, most of them are so big, then there's not economical, is not economical be able to do that infrastructures in the countries. So these LEO satellites could be a good complement to submarine cables. It's true that submarine cables get 98% of all internet traffic in the world, and in terms of connectivity between countries. But the main problem these days in most of the continent is how you distribute that traffic then locally to the populations and to rural areas where there's no coverage of fiber. So in that sense, I do believe there's a perfect combination. Is another technology. You needed more than one type of technology to combine and to be able to cover such areas, and being able to have the increase of utilization of internet in a continent like Africa, for example, but worldwide as well. Yeah.
Okay. And Azhar, for you, like coming in from a cloud perspective and virtualization, how do you see that, given your experience even now with the land-based telcos?
Yes, we've been working with a number of telcos. What does LEO really solve? Fundamentally, it solves the connectivity problem and fundamentally provides more avenues for these telcos to build edge services models. And what we see from a cloud perspective is that cloud footprints are expanding to the edge. Now we know, for example, some of the public cloud providers have already started to go deploy into the edge and far edge locations, maybe satellite, telemetry distribution centers, or remote locations. And we have extensive use cases in the industry, such as oil and gas, which I think Jakob already gave an example of in terms of offshore platforms, mining industry, where they are mining over large geographical areas, for which 5G is considered as a candidate, but satellite could be considered as another candidate for deploying and building better connectivity. Why? Because they want to be able to process that data locally. So now you have to extend the cloud footprint as well. Some of the challenges we've seen in working with telcos is for remote locations, the cells on wheels conversation, in terms of emergency deployment of infrastructure, mobile infrastructure. And these type of things can be easily addressed when you have reasonable latency or lower latency and high bandwidth connectivity. And today, the only way you do is a microwave backhaul. If you use satellite as a backhaul, if you use satellite, augmented capabilities for this type of high-speed connectivity, I think then you can actually do a lot in terms of in the areas of field exploration, in the areas of oil and gas, in the areas of use cases. So what I really feel is LEO provides that impetus to go after these type of use cases where connectivity was a premium. And once you have connectivity, then you can go look at deploying edge compute, you can deploy extension of cloud footprints, then you can actually then look at a whole bunch of use cases around that with AI, analytics, machine learning, blah, 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 and blah, right? So that's what really fundamentally it solves, in my opinion, a problem that is really important to solve.
Okay, so I want to mention something to the audience, that we actually can take in some of the audience questions later on in this panel. So feel free to share some of those questions. On the other hand, so what I would like to is pick up the thread on in terms of where we left off. Basically, so there is the issue of applications, there's the issue of technology integration, but to really have convergence between the networks, it actually needs more than just technology and proving the technology, right? So what could be some of the other aspects that can be challenges in terms of achieving this convergence between the industry? So if we have technology is one issue that needs, let's say, standards, as Jean-Luc has mentioned, what could be other things that can be potential roadblocks, and how do we go about solving them? So any thoughts on that? Like, and feel free,
yes,
I think Jean-Luc, you would like to go, yeah?
Yes, Frank, I would like to come back about one very important point which has been read by Azar, and which is what really Leo and Constellation solve. What is the problem which is solved? And a lot of times there is a kind of confusion by saying that a constellation resolve a problem of connectivity. That means that they bring connectivity where it doesn't exist any type of other connectivity. It's true, but not entirely. Because if it's just a question of bringing connectivity in some part of the world, you can use satellite, but not mandatory LEO. You can use traditional geostationary satellite, which do this job perfectly well. And with, on an economical point of view, a big geostationary LEO with a lot of power, which is focused on an area, is able to give some bandwidth with a much more better economical equation than a constellation which is spread on all over the globe and which spread its coverage on for a large part on water. Okay, the problem, the only thing which is not able to provide a geostationary satellite is short round trip delay. Okay, because for a geostationary satellite, you have half a second to go and to go back. With a LEO, you could have a very short round trip delay, few milliseconds, up to 15 milliseconds in certain circumstances. Okay, but we cannot say that the solution to bring connectivity, by instance, in a rural area or in some part of the world where you have not a local network, as has been mentioned, is constellation. Okay, the use of geostationary satellite is something which is perfectly suitable.
Yeah. So Jean-Luc, what I was really trying to say there is important, which is, I said fundamentally it solves connectivity with a reasonable latency, which is tiny. It's not half a second like you have in geostationary satellite, which means it actually rules out a whole bunch of edge use cases with a half a second delay in a geostationary. Whereas in LEO now it's possible to actually go deploy these new set of edge use cases that are really now reasonable because of that 30 millisecond delay or 15 millisecond delay or 20 millisecond delay, which is within, you know, the boundaries of almost the terrestrial experience as you'd get in that sense. That's what it's really solving, that particular fundamental case. So I have actually talked to people, you know, telcos here in North America, for example, where they're talking about utilizing LEO that could provide much better latency coast to coast than their terrestrial fiber infra that can provide from coast to coast. Why? Because it's one hop. Okay, which means now new edge use cases are possible, whether it's factory automation, whether it's industrial, you know, something else. From a coast-to-coast perspective in continental United States, which is more than 3,500 miles, you know, point-to-point distance, there you have now much better capability using LEO than you did have actually using fiber infra.
In theory, Azra, in theory, because after that, you are right, on a physical point, it's very clear that you can have a better coverage coast to coast using a very low orbital satellite than a traditional fiber, which will take 100 or 150 milliseconds, something like that. Instead, when using a satellite, you will have 20, 25 milliseconds. But after that come another problem, which is the capacity of the LEO constellation. Okay? Yeah. Because the LEO constellation is not very efficient on a throughput point of view and an economical point of view, is not really efficient. A pure geostationary satellite is much more efficient. And if a constellation is not efficient in terms of throughput when it costs a lot, after that comes the question of the price of the service, which is an issue. Yeah. And we come back to the question that was raised. What do we have to solve also to be able to use more the satellite, and especially the constellation and the LEO in our architecture? For me, one of the main questions is the price. If you ask what is the feeling about satellite technology in Africa, everybody told you satellite is efficient, but it's expensive. It's expensive and difficult to use. So will the LEO be able to solve this issue about the price and to deliver their connectivity, which is, and you are fully right, 100% more efficient than some other type of connectivity in terms of latency and so on, as a reasonable price? For me, this is still an open question.
Mm-hmm.
So
look,
maybe go ahead, Arthur. I'd like actually to cut you in and Jacob, yeah, go ahead.
No, it's something I discussed, and I had that conversations. I had a case of a geostationary satellite at cost of 300 millions, and just had one terabyte capacity. When I compare to a submarine cable that cost half of it, you could have 40 or 50 terabytes capacity. So it's true that the cost is a problem, and in Africa we feel that. We try to use satellite as a backhaul in the case of a cable failure, but it was impossible because the cost was pretty elevated compared to what our customers are willing to pay on submarine cables. But yes, LEO, I do believe that the cases that have been run on LEO satellites these days, they are taking consideration a different price tag for the services. So price will decrease and latency will increase. And I do believe that will open some use cases that are probably not in use these days with the traditional satellites.
Frankly speaking, sorry, please go ahead.
I just wanted to cut in, Jacob, because they're coming in from the application. What's your thoughts on this latency issue and pricing issue as well, given your working in the market?
I can agree with the previous speakers. But I think it's very important to come really from the application, the use case point of view, and then think about what's the best technology to fit in to solve that particular issue for that customer. If it's a shipment company that wants to get control over the machinery in that vessel still sailing outside the port and wants to have real-time information for a reasonable price, then I think a geostationary satellite is not always the way to solve this. And the third element, so price, latency is always important, but also related to the use case. But the third element I'd like to add to that is also seamless operation when such a device is getting into the area of the standard network. For me, my example, it's getting close to a port, etc., and then it's getting part of the terrestrial network. We shouldn't run into problems at that moment in time that there is no connectivity anymore, because everybody is starting to rely on that connectivity. So it's latency important, cost important, seamless interoperability important, but always related to how are we going to use it, because it should never be technology that is the first element, etc. It should be the problem that you want to solve, and then add the technologies to that.
Okay, good. So actually, we do have some questions started coming in, and some of these questions, we touched upon some of them, and some of them actually are what I'm going to address. So the key question here is that now we do see this kind of convergence. How do we achieve it? How do we accelerate it? What do we need to see from each part of the ecosystem to make this happen? Who would like to start to take a crack at this? In terms of how do we encourage this kind of synergies to happen? Like what do we do?
Maybe I must start this time, Frank. What I think are two elements. One I addressed shortly is we really need to cooperate between the two different ecosystems, satellite and terrestrial networks in coming up with a one standard, which should be part, from my perspective, on the 5G standardization and 3GPP, etc. I think that's absolutely important to bring the two elements together. And then the second part is we should not start from competition, but we should start from can we cooperate and then bring some extra value to society, to customers in that society, etc., which makes life better, easier to live, because it solves a fundamental problem. So cooperation is then the second element I'd like to bring to the table, which is needed in there. No competition, cooperation.
Mm-hmm. Yeah, I'm starting to see some cooperation. So if I see from a submarine point of view, terrestrial operators, most of them have some afraid of LEO satellites, and if they will stall some of his markets. I have not that idea. And I'm starting to see some LEO operators starting to approach us and say, okay, we need to transfer a big amount of capacity from one place to another place. So we'll take it to a specific country, and then they will upload it to the satellite and make the coverage of that regions, as they are not passing the traffic between one satellite to another satellite. So I do believe that complementary will happen, but I do agree with Jacob. So there's needs of cooperations between both or two or three type of different operators. And then there's always the technology needs really to speak on an easy way between them. So if we are not using the same standards, then will be more difficult. But I believe that should not be the main problem these days.
So I have a slightly different point of view. I think both Jakob and Arthur, already mentioned the cooperation and the standards portion of it. So I'm not going to talk about that anymore. I think that is an important point nevertheless, but there are niche areas, there are niche use cases in which it almost makes natural sense to use, a technology like LEO. If you look at, first responders, if you look at, emergency networks, if you look at how is the backhaul done in these situations? The backhaul is done today via microwave or satellite. That rules out a whole bunch of use cases when you do this type of backhauls. Using a LEO backhaul, now you can do analytics in field operations, right? Whether you're doing border patrol, whether you're doing, emergency deployment of something in these type of environments, it's absolutely, LEO can provide a big benefit over and above the typical rural internet, things that people talk about. If you're talking about, as I think Jakob already gave some examples of shipping industry, where they could benefit from these type of use cases. Now, in terms of how the question that you originally asked, Frank, is how do we actually go about integrating or bringing these ecosystems together? I believe there is a common way, because both industries are going through a transformation, particularly the terrestrial industry is going through a transformation in terms of software-defined infrastructure. That software-defined infrastructure allows them to be more flexible, more nimble in terms of where they deploy the infrastructure, how they deploy it, and how they turn it on and turn it off. I believe that can provide a clue in terms of how you actually bring the base stations, the base station controllers, the satellite uplink locations with the cloud infrastructure footprint in order to actually get best benefit out of both from the terrestrial and non-terrestrial infrastructure to be able to solve these type of problems and actually address these type of use cases that I described earlier.
Okay, so we are getting a bit more questions from the audience. I would like to, there's a very specific question actually that I would like, that's interesting, and I would like to pose it specifically to Orange and KPN. So Jean-Luc and Jakob here is about the new handsets that support more sub-6 gigahertz latencies, 2G, 3G, 4G kind, basically handsets straight to satellites. what's your thought about these type of satellite solutions? If you have any at this stage, you may not have looked at them yet, but
yes.
What do you think about those?
The question of the onset for LEO constellation is a problem which is not fully solved, okay? Because obviously, if you want to use this type of solution, as the satellite that you would need to use for your communication are moving, you need an onset which integrates on one way or another an antenna which is using phase array technology. Okay, this phase array technology exists. They are still very expensive. Okay, very expensive. Let's say too expensive to make the technology really usable on a very large scale. It was one of the problems that the guy of OneWeb was never really able to solve. When they try to enter on the market, they make a promise, and this promise was an onset, not really an onset, but a terminal for use, integrating a phase array antenna for less than $350. And they have never been able to solve that. When they bankrupt, okay, the cost of their terminal was more about 1,500 euro, which is 10 times more that they have promised. It's still an open question. If you are looking on the SpaceX technology on their Starlink project, okay, they are using some 19 inches phase array antenna that they design themselves, which are quite efficient, but remain also quite expensive. So this will probably be solved with a more large usage, but for the time being, it's still an additional question to the question of the global financial attractivity of the LEO solution.
Mm-hmm. And Jacob, from your point of view?
Yeah, I'm coming maybe from a bit different angle, and I realized that these devices could be very expensive. But think about what the value that could be created for a specific customer in a specific use case could be at the moment that he has real-time information available to steer traffic, to bring the maintenance of a ship to a higher level, etc., etc. What does it mean? And that, because then we're talking about millions probably. What's then the cost of a specific device of $1,000, $2,000 really mean if you can add that value to that case? So if we're starting to think about large-scale commercial consumer use, then the price of the terminal is very, very important. But if we start from the different angle and look from the value that we could create with these type of solutions, then I think the price level is already reasonable, at least coming into the right direction. If we are all paying $1,500 for an iPhone 12, etc., then $1,500 on a ship couldn't be the biggest problem. And then maybe the demand will grow. And with growing demand, I think prices will also go down and give us an opportunity for other type of usage, etc. First responders, if that's very important, is then the price of the device the most important aspect? I wouldn't say no.
Yeah.
So
I think that, sorry, Frank. I really think that the question of the economical equation of a LEO system is underestimated. Okay, it's true that the cost of a single terminal is not a key point. But if you make the global equation, okay, if you take, for instance, the case of OneWeb, okay, which bankrupt, okay, this system was planned to cost 6 billion of euro, 6 billion of euro for a global capacity which was 1 terabyte. 1 terabyte for 6 billion of euro. So you see that the economical situation was very, very bad. All the projects of LEO Constellation which have tried to launch focus on a very few limited number of use cases and on a very limited type of country. Basically, is mainly North Africa, because it's a country which have a large population to cover with some area with no other network, and people which are rich enough to pay for this kind of solution. And that's run. But if we are not speaking about a large usage of this technology all over the world, in Africa or in not such developed country, that just doesn't fly.
So I think just to basically add to this and comment in terms of the standard work and to answer this specific question here, or maybe add a comment on it. The work at 3GPP has been done basically by looking at the user terminal. So they're taking a different approach in terms of having the user terminals first talk to the satellite communication. So they're looking more of a user terminal centric perspective, right, in terms of their approach to that. But I just would like to go back to the main theme in terms of, I mean, today what I see in terms of convergence that we're really still at the very early stages, right? We have applications yet to be validated, the business models yet to be validated. Maybe we have to explore some new business models. But what do you think in terms of more non-technical aspect, and aside from pricing, how do you see basically that we can start to converge? Is there any other aspects, any other ideas that you think that we need to bring about, you know, especially related to the business models that could be completely different, right? I mean, satellite, for example, they've been selling in terms of bandwidth in megahertz, and they're slowly moving to doing megabit per second and services. Any ideas or thoughts on that aspect in terms of the services and the business models?
Well, we mentioned already a lot of problems. I think that another approach which have never been explored for the time being is to create some integrate use case, okay? Because for the time being, when you have to solve a solution, and I think it was mentioned by one of the other panelists, the solution, by instance, to make connectivity on a ship and so on, you have two pieces of cake. You have one piece of cake, which is a satellite. You have one piece of cake, which is the terrestrial, and you have to make the integration by yourself. You have to put the thing together, be sure that they are working together, and so on. Nobody has worked until now or something of fully integrated, and nobody is really able to say, this is a solution that you can use for your network or for your customer. You mentioned the case of 3GPP. It's very clear that 3GPP is starting to play a role in satellite. And by instance, if we consider 5G, 3GPP has standardized the air interface for satellite. It's the first time that this happened. So which means that in 5G, you can have a network core element which is connected using 5G directly to some user. It's the first time that this kind of standard exists. But nobody has worked in order to put really this solution end-to-end working and usable for an operator like us or the other panelists. So it's something that you have to make by yourself.
All right. So any other thoughts? Because I will try, we probably have about 3 minutes left. So I will start to wind down the discussion, but go ahead, Azhar.
Yeah, just one thought. I think the way I'm looking at this is a new technology. We look at this as solving a niche set of problems, or potentially a niche set of problems. What we need to understand is the implications of this particular technology and what are the class of problems that we need to solve together. For example, I would give you the set of assurance problems that you solve in a terrestrial infrastructure is the same as a set of assurance problems you would solve in a non-terrestrial infrastructure. The set of, data management solutions that you would build for terrestrial infrastructure, whether that's telemetry, whether it's, analytics, you would need to solve the same set. So there are some class of things that are common between the two domains. If we can come to that kind of an agreement in terms of that particular integrated solution that people are talking about in this panel, I believe there's some value in solving these problems and applying the same learnings that we've had from a terrestrial base, from a cloud software base, into this satellite infrastructure, extending those to make use of these type of different use cases, whether it's factory automation, whether it is, the shipping industry, that niche class of use cases, where I believe this will be just a hand-in-glove fit. I think the problem that people really are thinking is, well, LEO is going to solve all of my internet problem. I believe that's wrong. I don't think that's going to solve all of the internet, all of their problems.
So I think, okay, I'm going to start wrapping this down because we probably have 2 or 3 minutes left before our time is up. There are more questions coming in from the audience. Some of these related more to satellites that this panel is probably not the appropriate one to answer, but we will come back to, if we have the emails, right, or if we have the contacts, we will come back with some answers to these. I'm not sure about that actually, but in any case, to wind it down, I guess my final question to each one of you is, what is your ask of the satellite operator community? What do you like to see from them?
Cooperate.
Okay.
Yeah, I have the same word. I really like to cooperate with them and solve the issue, maybe from a niche perspective, but I see a growing demand in front of me.
All right, thanks, Arthur.
Yeah, the potential is there. So I do believe that they could interact. There is add value in combining them. So if they are willing to cooperate with traditional telco operators that are already implemented and that have some specific needs, the opportunities will be there for sure.
And I would extend that theme further and say, don't reinvent the wheel, especially in the satellite company. There are already a whole host of things that telcos have worked very hard with cloud providers to solve. Leverage that. Whether it is remote management, whether it is zero touch, zero trust, security, whatever they are, telcos know how to do them. Work with them, solve it.
All right. So obviously we're still at the beginning of what could be a long road, right, towards convergence, and I think there are still many other aspects to work out. I would really like to thank you all for your views and insights on this. And with that, I would like to close off this panel, and I will turn it over to Xavier Lebas for the second panel.
Thank you, Frank.
Thank you.
Thank you, everyone.
Frank.
Hello, everybody. Delighted to be here in participating in this workshop. My name is Xavier Lebas. I work for the European Space Agency, where I'm heading the future telecommunication projects. And today I'm very honored to be moderating this second panel that is composed by a group of global satellite operators. And we are going to be addressing LEO technology and deployment challenges in this panel, but we will also, in doing that, cover, of course, diverse solutions that the different panelists offer in the market, and also, obviously, the different interplay that these solutions have. I'm going to introduce the panelists one by one. I will start by introducing from Telesat Manik Binakota, who is the Commercial and Product Development Manager in Telesat. Second, we have Jasreen Ibenyaya, who is with Inmarsat, and she is the Director of Advanced Concepts and Technologies. We have next Philippe Yao, who is with Eutelsat and is the head of backhaul business line in the connectivity unit of Eutelsat. We have then Stuart Sanders with SES. He is the Executive Vice President of Technology, and he is also the O3b mPOWER program lead. And last but definitely not least, we have Mina Mitri, that is the co-founder and the CEO of Kepler. So, in order to set the scene, I thought of just putting a bit of context here. And the context is that we are undergoing a digital transformation of our society and of businesses. This digital transformation is supported by the emergence of 5G, 5G being the first telecommunication standard that includes terrestrial as well as satellite technologies. We see that this digital transformation has been accelerated by this unfortunate pandemic that we are undergoing. And we have seen that there is a higher demand for satellite connectivity. We would like to tackle, I will organize the panel in basically 3 blocks. One first block addressing broadband. And we are all aware, I think, in this forum of the need for connectivity everywhere. Services that in the past were niche are becoming mainstream. Services such as remote education and remote health, not to mention just the provision of access everywhere, what some people talk of as the digital divide. A second block is the block of narrowband services or the Internet of Things. And there we see the increase in the demand for autonomy. We see that in many different segments, business segments. And also there is a mounting pressure to optimize operational expenditures for many vertical business segments. So we have, as I said, a panel composed of global operators with a diversified spectrum of solutions that they are offering in the different markets. And we are hoping throughout this panel to illustrate what these different viewpoints are. So let me start off by giving the floor, obviously, to the panelists that are the protagonists of this session. And I would like to start with a block of broadband, where I will ask each of the panelists in turn to give a bit what is the position of their company offerings in the market of broadband. And while doing that, addressing the topic of low Earth orbit as opposed to other orbits and so on. So I mean, a bit of comparison of their offering. So I would like to start with Manik. Telesat is has traditionally provided broadband, or is providing broadband from GEO. And Telesat pioneered the use of the engagement into higher frequencies like Ka band. Now you have plans for a low Earth orbit constellation. So I would like to ask, while explaining what is the position of Telesat, that you are also addressing what is the role, in your view, of LEO constellations, and what is your unique proposition in that market offering.
Okay, sure, Xavi. Thank you for starting with me, and forgive me if you see me waving my hands like a madman at some point. I'm in a room with lights that may turn off. As you rightly mentioned, Telesat, we've been around for about 60 years now. We operate 16 GEO satellites, and we've been involved with over 100 GEO satellites over our 60 years. As we looked at our next 50 years, and specifically what do customers want? Today, we serve the enterprise market primarily, whether it's telcos for their backhaul, or whether they're service providers, internet service providers for anything that's flying or floating. We came to the conclusion about 6 years ago that a LEO satellite-based architecture would be best fit to meet what our customers want, what they want to do, and what can satellite do for the world of connectivity broadly at a global scale. So we've been chipping away at our LEO plans for the last 6 years. And we've come to a stage now where we will be launching a 300 satellite LEO constellation, which will go fully operational in about 3 years from today. And as you mentioned, it is focused on offering broadband. We are focused on solving the broadband problem for anything that is fixed or flying or floating, specifically focused on the enterprise and the service provider market, i.e. we will be the backhaul to the world, whether it is a 5G new radio, or it is an aircraft or a vessel. we are trying to solve the backhaul equation, which in our perspective is the biggest gap when it comes to remote connectivity, and of course doing it with the best quality, because low latency is definitely one of the dimensions of solving for the quality of the connectivity. But just learning from how 5G has revolutionized creating a fully programmable dynamic network, we want to bring the same flexibility and the same quality to the satellite industry, specifically to enterprises and service providers. That's where we see ourselves, and happy to elaborate more as we go along.
Very good. Thank you very much, Manik. Let me now turn to SES. Stuart, you have focused your broadband efforts besides GEO, that is your traditional positioning, into medium Earth orbit, MEO, with O3b. So I would like to ask, what is your view, the view of SES with regards to LEO constellations, and whether you have any plans in the respect of, or you believe that the mix of GEO and MEO is good for the markets that SES is serving?
So, as somebody who started with GEO, went to a MEO, ICO, if you remember ICO, many years ago, went back to GEO, went to O3b. I feel I've got a pretty good experience of the relative benefits of GEO and NGSO markets, and SES certainly has the scale, the financial capability to go and build a LEO constellation as well. But part of the work that we did after O3b was merged into SES to look at what we were going to do next to leverage NGSO, was to really look at that mix, knowing that neither one constellation was probably going to be the best go-to-market, not solely GEO, not solely MEO, but did LEO have a part to play? And we certainly looked at that in detail and took a decision that for the markets that we're trying to serve, and building on what we'd already done, which was already having established commercial operations in GEO, of course, but also in MEO, and being the first one to do that in MEO. That is where our focus is. And that doesn't mean to say that we don't believe there's a place for LEO in the industry. There certainly is, but it doesn't need to play a key part, let's put it that way, of what we're delivering. We will, at some point, I think, probably augment the system with LEO for very specific applications, but it won't be these 100 or 1,000 volume constellations. It will be very specific, bespoke solutions for maybe some in-orbited things or similar. Where we're really focusing is an integrated MEO, GEO, and terrestrial infrastructure play. More and more, we understand that what our customers are looking for is connectivity. They're not looking for a satellite solution per se. They shouldn't even need to care that it's a satellite solution. But if we can provide fiber-like connectivity, enabling, for instance, cloud at the edge of the network in a way that's not been done before, using all of the infrastructure we have, and combining the satellite segments with next generation terrestrial topologies using open standards, we think that's a very strong play, and that's where we're going to be focusing our time. Obviously, there are a lot of new entrants coming into the market, and we're looking at what they're doing, and some are somewhat separated from a business point of view, others are starting to overlap, and inevitably some of their business plans are morphing, I think, as they're starting to realize that it may not be as straightforward as they thought, but that's a normal business landscape, and we'll keep focused on what we're planning to do. So maybe I'll hand it back there.
Very good. Thank you very much, Stuart. Now I would like to move to Eutelsat. Philippe, Eutelsat is positioning itself on the provision of broadband from GEO. And with your recent Connect set of satellites with a very high throughput architecture, is that what is needed? And therefore, I mean, do you see a need of low Earth orbit for broadband, or you think that GEO is the right answer?
Well, I hope GEO is the right answer, or should I say, I guess we all hope that GEO is still an interesting and relevant answer to the market. So I guess at Eutelsat and within our broadband units, we have no doubt about that. As you may remember, we have been doing KA broadband for almost 10 years right now with KSat, which has been our first KA satellite, mostly over Europe, and also a bit of the Mediterranean and up to the Turkish and Russian markets. And it has been quite successful to deliver broadband basically to consumers and I would say SMBs. And then progressively, the more we've been delivering professional solution, the more we've been moving up, I would say, the value chain to more and more, I would say, technical solutions. So typically, as we speak today, in France, in Romania, in Poland, in Ireland, typically we are delivering 2G, 3G, and 4G mobile backhaul with KSat, with the pros and the cons, of course, of doing it with such a platform and technology. But the point I want to make there is that, yes, we believe that this kind of approach and this kind of geo broadband satellite are the right approach to deliver those kind of services. So as you gently introduced, yes, we are now moving to Connect, which is the next HTS satellite over Europe and Africa. And then we will be moving in some years to VHTS, which is typically a satellite providing in a range of 100 meg speeds into the download. So of course, we firmly believe this is the right approach for providing this kind of IP access to remote populations and SMBs almost all over. But of course, do we need LEO? Yes, we need LEO. I would say maybe we need LEO for two reasons. First of all, because they are already there. And then the second reason, I would say, at least this would be my own view maybe, is that I would say probably the question for us at Eutelsat and the question for me in my day-to-day job is not do I need, or yes or no, do I need LEO, but when I'm going to do it, or for which use case I would need it. And I think that Stewart just said it just before me, that probably LEO will be used for very specific vertical markets, some interesting use case and application. And by the way, but I'm already jumping probably to your next question, Xavi, is that yes, Eutelsat is entering to this LEO ecosystem in using it for the next IoT Constellation, which is the ELO project that we have at Eutelsat, which is now public, and which is Eutelsat LEO for Object, which will be at the end of the day a constellation dedicated to IoT. But I guess we'll mention that later. Thank you.
Very good. Thank you very much, Philippe. So let me turn now to Inmarsat, Jasreen. Obviously, I mean, you are a traditional, say, player in the mobile markets from Geo, and you moved in certain markets like the aero with your European aviation network towards a hybrid type of solutions, satellite from Geo and also from the ground. So, what is your view in general on low Earth orbit, and what is your view as Inmarsat on the provision of broadband services?
Thank you, Xavier. So Inmarsat, quick summary, is as you said, is a geostationary operator from heritage. The last 40 years, the company has been operating geostationary satellites, mostly for three key verticals: maritime, for commercial passenger connectivity, as well as for safety; aviation as well, for the cockpit communication and passenger communication; and enterprise and governments as well, with an enterprise heavy focus on IoT. Now, what has happened over the years is the company has evolved, and we cannot anymore kind of designating Inmarsat as a geo-only operator. As you said, we, for example, deployed our European aviation network, which is a hybrid of satellite coverage covering the entire Europe, and therefore benefiting from the values geo provide, which is this continuous coverage, and augmenting that with a network of 4G base stations deployed all around Europe. So there's about 200 base stations already deployed in partnership with DT. And those base stations have radio heads pointing towards the sky. And therefore, we're leveraging on this 4G technology to provide connectivity to all airplanes in Europe, reaching hundreds of megabits per second as a performance. So this is where it's a typical example where we're using the best technology available for particular markets. Another area where we're not necessarily a geo operator is for the Arctic coverage. So Inmarsat has announced that we are going to launch 2 highly elliptical orbit satellites for the North Pole coverage, providing Ka-band capacity and particularly addressing climate change, maritime markets, and the flight routes also crossing those regions. And so as a company, we have continued to make the choice of geostationary because we have deployed L-band and Ka-band satellite worldwide. And to take the example of Global Express, we have 5 global satellites deployed around the world, but we are about to launch 5 more over the next 3 years that are providing that augmented capacity, because capacity is not equally spread around the world. And that's the challenge perhaps the LEO world will have to face, is even though the aggregated capacity is huge, the per square kilometer, let's put it, it's a little bit different at a single point in time because the users are not equally distributed. Having said that, we still also believe that LEO has a place to play, and we're still figuring out where it makes the most sense and what is the strategy we're taking forward. And we're exploring everything from high altitude platform, LEO, MEOs, and above in order to continue remaining relevant for both the broadband and the IoT market.
Very good. Thank you very much, Jasmine. So last but definitely not least, Mina, Kepler has a constellation of small satellites. So in the area of broadband, where you are positioning yourself, what is the role that small satellites can play in supporting that broadband? And which vertical markets you think this is most applicable to?
Yeah, thanks for that, Xavier. So we have the benefit of having built, launched, and operated the network of small satellites that are delivering services here and now to the market. And so we've seen firsthand the benefits that LEO has been able to provide to many different verticals. And how we've narrowed that down is based on market demand. So primarily, we're seeing our ability to serve the enterprise market, similarly with service providers having a need for our service, requesting mass amounts of capacity. So what we've seen over the past little bit is just the accelerated rise of video, and the demand for video in a variety of different markets has just massively accelerated the amount of capacity that's being requested. And one of the key benefits of both small satellites and their operation in LEO is the ability to rapidly iterate and take different technology risk profiles to be able to address this insatiable need for capacity. And that's something that's not traditionally afforded with business models that need 15-year lifetimes to amortize their assets, and something we can do taking a page out of the terrestrial networks that are going into the market today. So we rapidly iterate on our model. We're able to provide services here and now. And for the majority of our customers, we're providing a complement to their existing VSAT deployment, where their traditional VSAT deployment might get them a 5 megabit per second data rate. And as soon as our satellite's in view, that capacity goes up to 150 megabits per second, and they can start to move mass quantities of data, whether it's for crew welfare, operations data, Arctic ice navigation, GIS information, and just a wide host of applications that they traditionally wouldn't have access to in the market, either because the costs were too high or simply their equipment wouldn't support it. And a key supporting factor is our ability to be backwards compatible with existing VSATs that are deployed out in the field. So customers don't have to pay for switching cost of new equipment, and they can immediately turn on to our network. And so we've seen that value proposition of a sort of tenfold improvement in data rate and a reduction in their cost of operations be very resident in the maritime markets, very resonant in oil and gas, very resonant in sort of enterprise operations all around the world. So to summarize, really, it's these small satellites that allow for very rapid iteration and different technology profiles that traditionally we wouldn't take in the sector. And now, because of these new satellite architectures, we're now able to realize significantly higher performance and data rate. And that's really just being met with a tailwind of rising in video distribution and video content needs. And that's really where we're seeing LEO have a great position in the market to support our kind of global demand for broadband.
Okay, thanks, Mina, for your explanations. So I would like to move quickly, and I'm aware that time is ticking very fast. So I would like to move into the topic of Internet of Things, and I would like Philip, you started mentioning the positioning of Eutelsat with Elo. So I mean, what is your view on how to address that market of IoT?
Well, first of all, as you may know, we are still working on it, so it's an iterative process. But yes, definitely, we believe that this project that we have, basically a LEO constellation fully dedicated to IoT, is probably and most probably the right approach for us. Hopefully, killing two birds with one stone, i.e. Addressing the IoT market, and I guess we all agree tonight or this evening that this IoT market is really booming and interesting, and that we all know that probably 75% of the population coverage of all the coverage on all the world is not properly addressed by terrestrial networks and operators, mostly because this is a sea, this is rural areas, this is the middle of Russia, of big markets in Africa, Latin America, etc., etc. So there is so much places where we have already existing objects with no coverage or very poor coverage. Okay, so this is one. And second, we believe that the beauty of the constellation for IoT is that with the, let's say, the dynamics of the constellation, the fact that we can upgrade and update as we progress into the rollout of the constellation. This is the right approach to engage with the objects and to collect the data we would get from those objects. So basically, the overview for us is to have this, again, LPWA architecture, so low power, wide area constellation, to be, I would say, an hybrid value proposal in addition to what the terrestrial operators are already doing. Okay, so as you may know, the Elo constellation, Elo projects, we are focusing on connecting Sigfox objects, on connecting LoRa objects. Of course, we are not ignoring the 4G or 5G NB-IoT protocols alike, and we will progressively, and we plan to progressively put them on board of the constellation. But the priority that we have for today is to make sure that we can, I would say, capture and hybridize all the, I would say, Sigfox and LoRa objects with this constellation. Okay, thanks, Philippe. I believe we have to speed up, to be concise in the answers, please, so that we can cover. We are getting a number of interesting questions, and I would like to have time for those. And I'm told that we have less than 15 minutes. So briefly, Yasrin, I mean, you're a traditional player in the IoT market with fleet data. So what is your view on the way of addressing that market?
So for us, we address the IoT market with what we have already, because we acknowledge the fact that the challenge of IoT is perhaps the technology, but is also the distribution, and it's a very highly segmented market. So what we make sure is we're really connected with those customers. On the maritime side, as you said, we have fleet data, which is providing an integrated solution with our current geo terminals, but also providing the data analytics and the edge computing that allows to have this digital ship capability, which is really ultimately what the customer is looking for. For enterprise business unit, we take a different approach, which is more having what we call big and M2M, which is a backhaul capability that is then connected to a LoRa network. And in that case, we benefit from existing technologies such as LoRa and sensors that are using that communication protocol that is very cost effective, and then backhauling that data over our network. So it's starting with the distribution and the market presence we have, and leveraging on our existing assets to unlock this IoT market. And as we see things unfolding with the newcomers, perhaps starting to evolve also our strategy to align with that. But we're starting with the distribution.
Very good. Many thanks. So that's a clear view. So Mina, you have a specific solution for IoT. Again, very briefly, I would kindly ask you. I mean, what is your main differentiator?
So our main differentiator is the high backhaul that we carry in our KU-band service that's being used in the variety of VSAT applications. What that allows us to do is, generally speaking, be protocol agnostic for a wide variety of supported protocols on the network. So at this point in time, we really believe in this idea of the non-terrestrial network work that's taking place both in LoRa-E as well as the 3GPP Release 17 non-terrestrial standards that are taking place. And to be able to support both of those applications, we're looking at transparent payloads, and those transparent payloads need a high capacity backhaul to be able to support the kind of mass quantity of devices that would be envisioned to be compatible both with terrestrial standards and with, whenever they're out of reach of terrestrial, be able to connect to the satellite network.
Very good. Many thanks. So I guess both SES and Telesat, I mean, you have a general purpose, say, solution for broadband, and unless I'm wrong, no specific, say, element to support the IoT. So Stuart, do you have anything specific that you would like to comment on? Otherwise, I would really like to introduce a couple of questions from the audience as soon as possible.
No, it's certainly within the scope of what the system can ultimately support, but it's not going to be a key delivery. The system is capable of so many more things. There are much more compelling business cases for us to address. One of the reasons that we will eventually launch, some form of LEO, I suspect, will be to address the IoT. I can see us coupling with another IoT specific solution and providing an overlay for that at some point could be another solution as well. But it's in the mix, but it's not a key part of what we're after.
Yeah, Manik.
Yeah, if I can just take a quick minute.
Sure.
The increasing ask that we see from customers is about simplification. Yes, you get a broadband pipe, which you can do all your customer or passenger or crew connectivity, but you might as well, as Stuart mentioned, put IoT traffic on it as well. Why simplification? Because I think customers are tired of trying to run and manage multiple networks, multiple beams. It's just getting too. We as satellite industry have to make it much more easier for the end customer to use us. So, for example, LEOs can be designed in multiple ways. We've taken a path where it doesn't matter where you are in the world, you'll be connected to one network. Doesn't matter if you are in one of the densest hotspots in the world. Take the busiest airport or the busiest seaport, you will get an order of magnitude more capacity than any possible satellite network can deliver. And security, it's all about, you don't want your security posture to be compromised. And when we did 5G testing on our LEO satellite we have today, not having to have these workarounds that we have today because of geo latency, which compromise the security of the network, you're done with all of that. You are as simplified as a fiber network. So it's about simplifying the network for our customers. And that's what we're trying to do with Telesat LEO.
Very good, thank you. And now I would like to turn into questions that we are receiving. And as you can imagine, there are many mentions of Starlink and Amazon and so on. So people are eager to hear what are your views. I mean, we got references to the Rural Digital Opportunity Fund in the US. How are the constellations, the endeavors of Starlink and also of Kuiper affect the dynamics in this sector? Who wants to start?
I'm happy to volunteer.
Go ahead, Mina.
So I think from our perspective, we've actually seen a very positive lift that they've been able to provide to the industry. Historically, I think we've seen the number of LEO broadband initiatives that have gone bankrupt is 0 at this point in time. And so getting some positive momentum in that way, having a sort of initial distribution of service has been really favorable for the sector at large. In terms of the thought around competition, we have to keep in mind that Starlink is going after a $1 trillion a year market, which is to say it's consumer broadband direct to the home. And that's not necessarily the same market segment for everyone else here, both on the panel and ourselves included, where there's enterprise markets and there's a wide variety. I'd also like to see the day that a single company is able to own a $1 trillion a year market. That would be very, very impressive, and certainly kudos to any company that's able to accomplish that. But given its wide swath, most likely we'll see a number of distributed players, especially with the fact that spectrum is a shared and scarce resource. So knowing that each company will have their share of spectrum, enlightened by the FCC's decisions to force spectrum sharing rules and a division of the scarce resource, we're going to see a number of players go out in the industry. But in general, I think it's been really positive and supportive to see that kind of momentum helping to lift the satellite industry from traditionally what were 0 players going bankrupt, not going bankrupt in the process, to hopefully one that we'll see in the process.
Very good. Anybody else wants to address the question?
Yeah,
I'll go ahead.
Go ahead, Yasrin, please.
Yeah, I was going to say, we also see a competition a healthy thing. So we welcome, because it fosters the ecosystem and perhaps make, for example, the terminals more cost effective. We can see the biggest challenge here is making sure the terminal are reaching the price points that it can achieve the mass market it's going after. And until we have affordable flat panel antennas and a small integrated low-cost terminal, that untapped market will not be unlocked by the space industry. The mobility market is saturating. There's already existing players, so this is not where really the danger is at this point in time. And the other challenge related to mobility market perhaps is the fact that for those mega constellations to provide truly global coverage, they need to have a ground station in line of sight of that LEO satellite at every single point in time, which is perhaps easier in the landmass, much more difficult in the middle of the ocean. So things are very complementary until we start seeing perhaps inter-satellite link solutions that will challenge this assumption I'm making. But for me, the key problem here to unlock this trillion market is very much the terminal.
Very good. And Manik, you wanted to complement, please.
Going back to FCC's art of they've full kudos to FCC to prioritize low latency as an important variable as part of the bids, and no better argument than one of the biggest regulators prioritizing low latency. If you don't have below 100 milliseconds, they've said it impacts customer experience. And though we are all competing, I think it's heartening to see Starlink wave the LEO flag up there, and it helps the overall satellite industry.
Very good, very good. And maybe a last question. We didn't have time to roll out all the different topics that I wanted to go, but I mean, maybe just in a few seconds, anything that you wanted to say about integration with terrestrial networks or the internet networks in general. I mean, what are the key aspects there? And quickly, because I mean, we are really in extra time almost. So Stewart, please.
Yeah, look, this is a key part of the infrastructure that we're building out. I think one of the key features of doing it is to work with open standards. We've seen, and including the space segment layer, particularly space segment layer, customers who've really been fed up because they've been locked into particular vendor solutions of proprietary interfaces. That is not, we think, the way to go. In the space segment, it needs to be open. It needs to be effectively a sophisticated bent pipe. And at the ground segment, go with open standards, leverage what the industry is already doing. We're a very small part of the telecoms industry. And while we're very sophisticated at some things, on a lot of other things we're not. And that stuff can, you know, work across the networks. You know, we've already run, we're the only satellite operator, I think, still that is MEF certified. And we can see the use of ONAP and open standards, open BMIP, AMIP across the network. Just leverage that. That's the way to get integration. And then you start becoming relevant to cloud providers. That's why we have the relationship we have with Microsoft, for instance.
Okay, very good. Anybody else wants to comment on that? I mean, Jasmin, you mentioned earlier and the alliance and the shared network with Deutsche Telekom. Anybody wants to add something to that? And then we Manik. Oh, Philippe.
Well, no, just adding that on what you guys were just saying. I think, yes, where we all have an opportunity is with this 5G dynamics and this NTN program that are starting to being funded and developed and supported by the ESA, notably. Thank you for that. And so there's I think our industry has a tremendous opportunity to embrace this 5G call for open standards and to make sure that, as exactly Stewart was mentioning, yes, we might be very good in the air, but on the ground, we definitely need to open our platforms, to open our standards, and to make sure we can speak to any telco in the world almost seamlessly. And of course, I think this is the biggest revolution, at least for us, which I would call that simply an IT revolution, rather than it's not about RF frequencies, or even though we want to have new modems and affordable remotes, I think the big revolution for us is IT right now.
Very good. I'm afraid that our time is up, and as I said, I mean, I had many other points. We will leave it with the point of Philippe on the revolution, the standards revolution. I would like to thank you, my dear panelists, for making this session enjoyable. I had plenty of questions that were coming through the chat that I would have liked to address, but unfortunately we have to move on. So thank you very much for your participation in this panel, and thank you for the audience to be following this debate. Thank you.
Good afternoon, everybody. This Space Internet workshop brings in experts from the telecom, internet technology, and investment value chain, and assess the latest space internet development. As you may know, this workshop is a continuation of a similar one hosted in February this year in Barcelona. In this event of today, we want to discuss obviously the trends and technological level, but also at investment level. There is a new ecosystem in front of us with different vertical and sectors that LEO can serve, and therefore the possibilities and business models that can emerge are multiple. Obviously, there are big players and small players as usual, but being a new economy opens the door to many innovations and opportunities for startups. There is also a new opportunity for investors, as despite being a new market and so its risks involved, it's very important to choose those who can position themselves first and get their niche market. So what we will try to understand today from these panelists, this great list of panelists, is what are the challenges that startups have to face? What are the business models that they foresee with LEO? The type of projects and companies that venture capitalists are interested in, and what they invest in. And finally, what is International Finance Corporation World Bank Group position with regards to this? So today we have with us the first panelist, Henry Wong. He's the president of Smart Mesh Foundation, co-founder of Singapore Blockchain Living Lab, president of the International Blockchain Applications Federation. Henry Wong's mission is to build Internet of Value ecosystems using smart mesh, peer-to-peer mesh network. An interplanetary distributed and self-organized mobile mesh network is being constructed by Smart Mesh to support a wide array of next generation edge computing, edge storage, edge intelligence applications, and decentralized finance applications. Smart Mesh and Meshbox can be integrated with LEO constellations to form space group integration network to connect the unconnected and bank the unbanked. So the first question for you, Henry, today is how to effectively provide inclusive connectivity before the LEO constellations are fully built.
So hello, Monica, thank you. So hello everyone. So LEO constellations are developing very fast, but before they are fully built, more than 3 billion people still have no internet. So it is very painful to live in the unconnected environment, especially during COVID-19 pandemic. So how to effectively provide inclusive connectivity? So first, in areas where there is no LEO internet coverage at all, and we can use Meshbox and to form smart mesh network to connect people with local mesh network. And both smart mesh and Meshbox are blockchain based. So which means every mesh node is incentivized and by tokens to provide mesh link and bandwidth sharing and distributed storage. So the internet uplink and can be geostationary satellites, fibers, 4G, 5G, and white space. And the uplink is shared within the mesh network and cached by mesh boxes to provide much better user experience and with limited throughput. So second, in areas where LEO constellations begin to provide intermittent services, and Smart Mesh can provide offline payment solution and with secondary layer called Photon network, so that inclusive financial application and can provide services. Even the connectivity is gone because there are not enough satellite nodes to provide high quality services. So before the LE constellations be fully built, and Smart Mesh Meshbox actually can help the inclusive finance applications still running even without internet or intermittent internet. So that's the solution and for now. Okay, thanks, Monica.
Sorry, thank you, Henry. Next panelist that we have here today with us is Edward Danielian. I hope I pronounced it correctly. So Edward is the global lead for mobile network operations and satellite at the International Finance Corporation, a leading provider of financing to the private sector companies in the emerging markets. In the last 10 years, Edward was involved in financing or closely followed projects in the satellite sector, including a number of MEO and LEO constellations, IFC views and satellite sector, and especially LEO constellations as a critical element for bridging digital divide. So my first question for you, Edward, today is there a winning financial strategy for LEO constellations, do you think?
Yeah, thank you, Monica. I think it must be, because I mean, financing is the key element, and maybe even as challenging as the technical solutions necessary for LEO constellations at this point. And I think, I mean, this is what the sector itself is trying to figure out. I mean, what is the right way of fund these projects? And honestly, we do not have a sort of very long track record. I think it's probably, if you're looking at no geo constellations, it's only O3b who basically, I mean, just paved the way and showed how it can be done. And it's important because we also have, I mean, quite a number of constellations, I mean, being developed or proposed pretty much at the same time. I mean, a lot of them are, we're talking about, I mean, several $1 billion, I mean, way up there. And they may be competing, not always, but I mean, sometimes competing for the same source of funding. So I mean, finding the right kind of a financing strategy is probably what make a difference between the success and failure of a project. And if you sort of try to look back and just think about, I mean, how to sort of, in what buckets, I mean, put different strategies. And probably one most obvious would be the project finance approach. I think, I mean, this is something that that O3b pursued, I mean, substantially. And I mean, it's more complicated, time consuming, but at least, I mean, this is something that has been tested both in the satellite sector and outside of the satellite sector in other sectors. So it has some kind of credibility and track record. And for this, I mean, typically, I mean, whatever export credit agency and development financial institution that probably would be playing, I mean, their respective roles, including IFC. And another approach which sort of I see happening is sort of more VC strategy, probably I would label it. And this is effectively just trying to fund everything with equity up to a point when you basically turn into profitability, at least, and project becomes, I mean, bankable. You can just raise debt, which is, I mean, probably fine. I mean, for a project which is, I mean, whatever, $5 million or $50 million or $500 million. But if you're talking about, I mean, billions of dollars and pouring all this equity without, I mean, clearly understanding when things will click and start working, is maybe a bit of a risky strategy. And I do not know. I do not have an answer. I understand, I mean, from some different reports that probably, I mean, SpaceX is trying to do that, pursuing this strategy. I understand that OneWeb was, I mean, it was one of the strategies, I mean, pursued by OneWeb, and then probably did not work out, I mean, too well. So it may work, but I mean, I honestly, I'm just very sort of sitting on the edge of my seat and just trying to see, I mean, whether it will or it will run out of fuel at some point, because it's effectively it's a single asset project, meaning that, I mean, either you build it all, yeah, or it won't work, or it won't work properly. And the last one is sort of more obvious, which is, I mean, trying to do it, I mean, to build it, I mean, under your, I mean, own corporate roof. I mean, this is probably true for, I mean, smaller constellations. And again, I think, I mean, Eutelsat is probably, I mean, with the IoT constellations, just trying to use the strategy, relying on their own sources, doing it at the corporate level. So I think, I mean, this is where we are, and I think time will show whether any of these strategies or some other strategy or combination of them would bring success.
That's right as well. Time will show. Thank you. So we have with us also today, our next speaker is Brian Halls, and I would like to introduce him. Over 35 years of progressive space system engineering and program manager. Provided executive leadership of large multidisciplinary teams developing complex commercial and governmental space systems using state-of-the-art technology. He's managed $1 billion projects to cost and has experience working with large investors, raising equity and supporting multi-phase boards. Built to startup companies from the ground up. CTO at O3b Networks helped OneWeb raise its initial capital and was the first CEO of OneWeb, setting up the joint venture with Airbus Defence and Space and its operations in both the US and France. Bachelor of Science in Aerospace and Ocean Engineering, and he's also Master in Science in Space System Engineering from George Washington University. Quite a lot of things. I've got a slightly more technical question for you, in fact, system, because I come from the Earth observation type of space projects. And we use a lot of the LEO orbit usually, but LEO, MEO, HEO, GEO, actually, does the orbit matter? That's the question I have for you. Does the orbit matter for these type of projects?
Yeah, it does. And very similar, for very similar reasons as you would in Earth observation. I think you'll see some similarities as I talk through it. But the orbit is a key trade, along with, in communication systems, the efficient use of spectrum. In an Earth observation system, it's the efficient collection of photons. And you know, from a communications viewpoint, LEOs are actually, in my humble opinion, the worst choice for just about every reason outside of network latency. And if you look at the field of regard of very low Earth orbit communication systems, you're covering an area the size of Texas or the size of Spain. And if your network has to connect outside your field of regard, you're starting to lose the benefits of your latency to that one satellite. You're going to approach the latency for general content to a regional data center like a terrestrial network once you go off the satellite. So the latency issue really gets overstated, I think, when you start looking at it from a network topology. So backing away from that, just like an Earth observation system, you look at coverage, and on the Earth, population density is not uniform. Matter of fact, it's still very concentrated, and about 90% of our population is concentrated in less than 8% of the Earth's surface. And that leads to some very difficult things to overcome if you're in LEO. So being very close to the Earth, your field of regard is small. The population density is in a very small area. So the utilization of an individual satellite is very small. In a 400-kilometer altitude, you're probably using that satellite 5% of its time in orbit. If you're higher LEO, it might be a little bit less than 20%. And all of that drives to different aspects of the business in terms of cost, the amount of capital you need to raise to get global coverage. And I think that's the biggest challenge in systems like Starlink and OneWeb and eventually Kuiper as it's coming along. That if you're at 400 kilometers, you need 4,000 satellites to get Earth coverage. If you're at 1,200 kilometers, you need nearly 700 satellites to get the same coverage at a reasonable elevation angle, so that you can actually communicate in a community with buildings. So that drives a lot of things. And I'm not even going to address the user equipment issue yet. If your business model is direct to home, when you have to track low Earth orbiting satellites, that's a different question, but that's a significant amount of capital in a business plan. But back to the orbits. So LEO, I mentioned 5 to 20% utilization. If you go up to MEO and HEO, you can achieve, and if you're in inclined orbits, you can achieve roughly 70% utilization. And in equatorial orbits like O3b and mPOWER, it's 60 to 70% utilization for those satellites. And GEO, if you're under your orbit slot, you're going to get nearly 100% utilization. So that's the trade. It's how do you use the satellite? What is the network solution you're trying to get to? And that utilization becomes the biggest driver in cost. So if I do a quick parametric on that, if I provision a LEO system at a megabit per second per user, which works out to be about a 300 gigabyte per month plan, and I take into account that utilization, a single LEO satellite may be able to serve about 1,000 users at max with the spectrum that it has. If you take that up to MEO for a system like mPOWER or the system we're designing for Mangata, that gets up to over 25,000 users. And I'm just using that metric to give you a feel for the scale and of the issue with LEO. then if you monetize that at $50 per month for 300 gigabytes, which, 5 years from now, that you might even be lower cost than that, but just to state it, it would take a large LEO constellation more than 10 years to repay just the capital before it makes profit. Just to give you the financial implication of that. In MEO, it can be less than 5 years for that same cost, just to get an apples to apples comparison. So yeah, the orbit has a big impact on how you implement networks. So if you're looking at a network that's outside the area of a typical state in the US or a reasonable sized country, the benefit of LEO goes away, and the cost of implementing that system really makes it hard to create a profitable business. So the MEOs also allow you to scale, so you can deploy the system with lower capital up front, and then as you expand, you're getting that capital deployed closer to getting revenue off of each deployed satellite. So it's just a much better approach for communication systems, I think, and that's will play itself out over the next few years.
I agree, Brian. Thanks. I need to ask you to remind you to stick to the time if it's possible. Next speaker is Jaume Sanpere. This one I do pronounce it correctly, I hope, because he's also Catalan. So Jaume is co-founder and CEO and president of the board of directors at Sateliot, the first satellite telecommunication operations that will provide global and continuous connectivity to all the elements that will make up the IoT universe. He's MBA and PhD of IESE, expert in business development, product manager, mobile telecommunication, wireless technology, and above all, in-depth knowledge of the telco and satellite market. He's experienced CEO with a large professional background in telecommunication industry. Jaume is a classic in technological entrepreneurship in Catalonia. He's founder of various companies, mainly telecommunications, and I think he has an extensive CV, but we'll be here. So my first question for you is, can you briefly explain how to fund your Sateliot project? And what are the difficulties that you are facing for doing this?
Thanks, Monica. Thanks for the invitation. Of course, to fund a company like Sateliot IoT, it's always difficult. Okay, a space company, long-term companies, as the other panelists explained. Okay, this is something that the reward or just the sales doesn't come in 1 or 2 years. Okay, it takes a long time to have everything. We choose IoT because different from broadband or voice, you do not need to deploy the full constellation. There are a lot of applications in IoT that they do not need real time, that you could start selling much faster than in broadband. Yeah, we plan to start selling with just 16 satellites, and we have seen that there is a lot of use cases, okay, that could be used with this small constellation. And funding, it's always the same. Okay, it's being very resilient, because there is a lot of no's till you get a yes. Okay, then a lot of presentations. Venture capital have to be specialists, because as you know, this is a very concrete part of the deep technology sector that, of course, if you do not understand it, it's very difficult to invest in. And finally, to do not help, but just in contrary, okay, we luckily have not been the first to arrive into the market and say that we want to design LEO IoT constellation. Then we have a lot of, okay, another IoT constellation in the market, and we and I love that, because I really believe, okay, that my experience and the history of the telecom market says that standards takes all. Then and here will happen exactly the same. Okay, for first time in history, mobile and satellite will be joining, will be merging, okay, under the same standard, which will be 5G, and this will mean, okay, that all these IoT LEO constellations will have a very difficult life when 3GPP, not because of us, okay, we are just we're just on the loop, okay, but when 3GPP approve the NB-IoT NTN, non-terrestrial networks, this will mean that exactly the same equipment will be using mobile and satellite. And one of the big issues, which is the economies of scale for the user equipment, will be overcome.
Indeed, yeah. Thank you, Jaume. Our last speaker today is Luke Moloney. He's a software engineer, impact angel investor and space enthusiast, like all of us, by the way, from Vancouver, Canada. Luke is a general partner at Space Fund, a VC firm dedicated to expanding the high frontier by fostering space technologies companies. Luke believes that long-term space investing is the highest impact investment sector, as it allows us to overcome current and future essential risks and reap great rewards. I fully agree with him, by the way. And my first question for Luke is, what do investors look for as key success factors when selecting the target companies?
Thank you for the introduction, Monica. Hi, everybody. As for what investors look for, I think they look for probable return, high return on their investment. And that's a challenge in the space sector. It's a challenge in any sector, but like Edward pointed out, that the VC model for the space industry is a little bit challenging for some reasons, including that the time to exit can be very long term. And a lot of investors don't necessarily have the patience for these really long turnaround times in this industry. So at Space Fund, we have a particular set of strategies and investment theses that allows us to get to a return on investment or an exit faster than the general space sector. So the things we look for are companies that have a really innovative technology that's expanding the realm of what's possible in the space sector, but they have a product or a service to sell soon. So we've invested, for example, in some middleware companies that provide technology to other manufacturers. We've invested in rideshare companies rather than in launch companies. We've invested in, for example, we're going heavily into optical communications for satellites, both inter-satellite links, satellite to ground, and satellite or ground to deep space. So that's generally what we do, is we look for companies that have a product that's going to be usable near term. But at the same time, there's a bit of a chicken and egg problem. If we want to support a technology that will open up a market sector that doesn't yet exist, how are we going to do that? On-orbit servicing is an example of that. You can extend the life of satellites by providing service machinery to them, like basically tugboats in space. There's not a lot of customers for that because that technology doesn't exist, except earlier this year, there was a high-profile use case of a geostationary satellite whose life was extended by one of those. So yeah, that's generally our strategy, is we look for near-term opportunities.
Thank you, Luke. Okay, now I'll have a second question for Henry, but I really ask you, I think you did actually stick to the time, but I repeat, I insist on trying to stick to the time. So Henry, I'm concerned myself about overcrowding a particular area for space. So how smart mesh can help to solve the problem of overcrowded LEO constellations in the future? Henry, you're muted.
My concern. So, the starting to launch like 42,000 satellites, right? So that's a lot. I mean, they already create a lot of problems now, and will have a big impact. I mean, in the future. So just think about the number, okay? And in addition, and I think the company and the constellations in China will launch 13,000. Okay, so I think that's that's not included like OneWeb, like Kuiper. A lot of like constellations will emerge. So our space will be overcrowded. I don't think the LEO constellations mean that everyone own a terminal and connected into the LEO internet. It should not be used in that way. So that's a great waste of resources. And that could bring a lot of troubles to our Earth. So the astronomy observation is one. I think, because these satellites, because they need like the positions and all this kind of bandwidth sharing, so that can bring a lot of issues, even including political issues. So that's why, and we need some consensus. And also we need to solve the overcrowded problem. So smart mesh is, use the mesh network with consensus coming from the blockchain, so that this blockchain and have a protocol, and it's much thicker than the TCP/IP because they have the billing functionality and distributed ledger and in this protocol. So they can empower the community and to build their mesh network by themselves. So one terminal can be shared by a village or by several households. So in this way, and it's reduce the amount of the satellites needed and for the communications, because the smart mesh enable the bandwidth sharing. Also Meshbox have distributed storage, so a lot of cache inside. And for many locations like education, universities, and a lot of like traffic, it don't need to go to the satellite, and they will just actually circulate within their campus. So smart mesh can actually reduce the amount of satellites needed. I mean, in the future, it's very important. Okay, thanks, Monica.
Thank you, Henry. And Edward, linked to that, I'd like to know what lenders are looking as they assess the LEO constellations. Can you help me with that?
Yeah, sorry, Monica. It's a loaded question. I'll be able just to talk about it for the next, 2 hours that I don't. But I think that, the fundamental question, at least, for lenders is, how do you make money? Whether you're talking about communication satellite, whether you're talking about Earth observation or IoT constellations, how do you make money? And probably it can be sort of split into a couple of three, fundamental issues, right? One is, how do you sell? Because, nowadays, building a constellation, launching it is not a rocket science. Rocket science is how you sell all the capacity which you introduce. How do you deal with a multitude of countries? How do you try to line up, the logistics and customer service and all the sort of issues without which, and regulatory, which is, a big factor, without which, sales, will not, if not impossible, but very, very challenging. It will take a significant amount of time. So go-to-market strategy is probably one of the first things I would probably take a look at. The second one is how you implement it. And in order to implement things successfully, what you have to do ideally is to have an experienced sponsor of a project with ideally with some kind of strong track record, institutional track record, ideally. It doesn't mean that it's absolute must. We've seen quite a number of, just Pacific is one of the examples when you can just do it, without these elements. But we should expect that I mean, LEO constellations would most likely will take much longer to ramp up, I mean, to the necessary level. And for this, I mean, you need someone who will be able to step in and provide, I mean, contingent equity, contingent funding, support, whatever is necessary in order to just bring the constellations to the level when it can operate, I mean, successfully. And the last one is probably look at the fundamentals, I mean, so strategic, fundamental. What is your competitive advantage, and is it going to be there in the next whatever 5, 7 years, whatever 10 years, whatever the life of the loan is going to be? Because I think what is happening, a lot of constellations, or a lot of ideas are based around the technical solutions. I mean, what constellations can do and how exciting it is. But I mean, people have to remember that, I mean, just taking picture, even a better quality, or just providing connectivity-based connectivity, it's commodity at the end of the day. And tomorrow it will be someone else who will be able to come up, I mean, with a better solution, I mean, better resolution, better speed, whatever, I mean, lower latency. And I think, I mean, a lot of constellations who are looking for debt financing should also think about, I mean, how they retain this cutting edge. What is going to be the sustainable advantage in the next, I mean, several years in order to give confidence to the lenders.
Okay, good. Thank you, Edward. So a question for Brian now. After a nice assessment on the different orbits, tell us, how do you see the future of satellite integrating with 5G technology?
Yeah, I think I'm going to elaborate a little bit more on both what Henry and Eduard said. I think as you go forward, and especially with 5G networks, capacity is going to become less and less of a benefit in terms of how a business generates revenue. You're going to have to get into network solutions. We're seeing that with what we're developing from Ingata Networks. 5 years from now, you're going to see the average user use 4 or 5 times the amount of data per month that they're using today. You're going to see the household go from 100 gigabytes a month to 500 gigabytes a month. And satellite by itself is never going to catch that curve. So I think you're going to see what 5G offers to satellite is the ability to integrate more effectively into the network. And I think from 5 years from now, you're going to see a lot more of distributed processing, of distributed cloud services, and those tech capabilities are going to move further and further out on the edge, and you're going to see more and more private networks as well. And I think that's where satellite needs to position itself, because you can use mesh networks to thin the traffic over the satellite and make it a lot more effective, which allows you to make the use of the satellite more sustainable. MEO, coming back to that, you can deploy the same amount of capacity with 15 times fewer satellites roughly than what you need in LEO. So it can be more sustainable. You can more effectively use the spectrum. And that leads to businesses, again, that you can also scale, which is important to lenders. You have to be able to show you can enable the business plan, operate the business plan effectively, and then scale over time, which gives you the ability to migrate technology into the satellite system. If you're deploying 4,000 satellites, it's really, really hard to change the technology, and you're building that whole business on that network. So I think there's a lot of better choices out there, and the way the 5G is moving offers and opens up a ton of opportunity if you can integrate terrestrial networking and terrestrial compute with satellite in the proper way.
Okay, good, thanks. Now, Jaume, can you tell me in 1 minute, see if you can make it in 1 minute, regarding the regulation issues, it's important. Is it possible to enter a market like satellite telecommunications?
Yes, we are doing okay. Of course, you need a lot of a deep knowledge of the regulation. Okay, this is a specialist item. Okay, that is not easy to find on the market, but you have that right knowledge today. With before than today, okay, the geo was much difficult to enter, okay, because there was the position of the satellite, that it was a very close market with very few positions available. But in LEO, you could apply to the ITU, okay, for frequencies, and if you do it right, and after you do your work in coordinating your frequencies with the rest, and in IoT that you need very low frequency spectrum, okay, that's something that it's important, okay. It's clear that you could enter, and it is a space for some of us.
Great, thank you, very clear. I'm going to, nice, yeah. Look, I'll take a question that is from the audience, but I found it interesting, and I was thinking on those lines as well. So I use a question from the audience for you. Do you not think that the lack of frequency spectrum and the encumbrance just sitting on it is one of the most blocking factors for new systems and new companies? What do you think?
Lack spectrum, yeah, that is a big challenge, and I see it as an opportunity from an investment perspective, because it's going to drive innovation of new technology, and like I implied earlier, we're really interested in optical communications technology, and there's several companies that we're invested in, and a lot of interesting new technologies, including retrofits to existing satellites to expand their downlink capacity by relaying 2 optical communication satellites which come down to the Earth. Yeah, that is a big challenge, and we're not going to see a reduction in the number of satellites launched. We're seeing a massive increase in the number of satellites launched, including Earth observation satellites with hyperspectral imaging and other sensors that need a lot of bandwidth to get the data to the ground. And we're also very interested in ways to not get the data to the ground, but still make it usable, including in-space storage and processing. And along with that comes, of course, IT cybersecurity issues in space. So that's another sector we're very interested in, space-based cybersecurity. So yes, great challenge and great opportunity.
Good, thank you. Henry, I'd like you to make your last statement on how to contribute to interconnection and intercommunications of many different constellations.
Yeah, so I'm not sure how many people know about the original concept of our internet. So it actually, the idea is from the first satellite launched by Soviet Union. Okay, so the founding father called Licklider, and at that time, and he proposed in 1962 proposed intergalactic network. So and then became the ARPANET, and turns out eventually become our internet. So the internet came from the idea of a satellite. So nowadays, and we are trying to build the LEO constellations to build the real intergalactic network. So that is very exciting. Okay, but so many LEO constellations, but they don't work with each other. So every constellation will launch so many, satellites. But this is not the original concept from our founding father called Licklider, and it happened. He is the fellow alumni of me. We both graduated from the Washington University in St. Louis. Okay, so for the constellations to work with each other, and we have one solution. So this solution, and we, is designing on the ground for mesh box, every node, and they form a mesh network. And we combine the wireless signal and with cryptography, so that they can prove they form a mesh network, and they are doing their work. So, and this proof of mesh actually can be used by the satellite constellations, so that each, the satellites in different constellations, and they can work well with each other because there's a cryptography to guarantee, and the nodes and in different constellations are contributing to each other. So that's a solution we think we bring to the, the LEO constellations. So I think the LEO constellation is very important to build the value internet, and it's fully decentralized.
Okay, good, thanks. Okay, Edward, in 1 minute, see if what is the role of the emerging markets for LEO constellations? That's important. See if we can, what you can say about this would be more in 1 minute.
Look, I mean, it's an easy question, Monica, at least to me, because I don't think that any LEO constellation, because of the very global nature of the constellation, can be successful without, cracking the emerging markets. And this is the biggest opportunity, but also this is the biggest challenge, because there's a lot of problems in the countries. Having sort of big credible off-taker, regulation, role of the government, universal service obligation fund, etc., etc. There's all problems that need to be solved. In country by country, and we're talking about dozens of countries. And this is one of the reasons why we see that IFC's role is probably will extend and beyond providing financing, equity or debt, because I think we'll be able just to help facilitate adaptation of this capacity of these satellite-based solutions in the emerging markets, and make the LEO constellation successful by themselves. Did I make it in an hour?
This is great. Yeah, this is great. You did very well. Okay, so one more now for Brian. So Brian, you think that new entrants are disrupting or changing the market, right? So why do you think so?
Well, I think in context of how to apply current technology as fast as you can, that is largely the reason why. I think new entrants are much more nimble with technology. They can more effectively understand how it's used and more effectively react to changes in the market. And that's kind of what we're seeing take place today. And there's a big transition happening between large entrenched, from a satellite viewpoint, between large entrenched manufacturers, large entrenched operators, towards companies that are carving out niches and attacking the market with different ideas, which is all great. And I think you're going to see that continuing to happen going forward. A lot of the capital coming into the market that's being invested is allowing that to happen. And going after emerging market is super important as well. And that's finding a way to bring that cost of technology to the solution space that's needed in the emerging market, which, it's going to be cost driven. There's digital literacy issues, and how to use that digital technology. And there's applications that can address that today. And there's getting content that is desired and wanted out to the edge of the network. And all of that is coming together in a very, there's no large company that's doing all of that today. So there's big opportunities for new companies with new ideas to go right to the market. And that's different than what it was 15 years ago.
Right, yeah, indeed. Thank you. Jaume, one more for you. And I insist that you take it as a final statement if you like. But you talk a lot about standards, but the satellite world is proprietary. Is it changing? Will 5G really be different?
For sure, Monica. 5G, it's much more than a standard. It's a group of a standard. And 3GPP has already demonstrated its ambition when set up the group of Narrowband IoT, NTN, non-terrestrial networks, that, as you know, the 3GPP is the organization that set up all the standards for the mobile industry. Then, without any doubt, in broadband, it will take a little bit longer, but in narrowband, the future is a standard, and the standard is 5G.
Good. I'm sure. Thanks a lot. Yes, very clear. Luke, last one for you. I know that you are a little worried about these carded and lost data, Earth observation constellations that are majority of the constellations discard quite a lot of data from your point of view. You want to say something about this, or you take it as a final statement? I insist, in 1 minute.
Sure. I mean, briefly, these Earth observation satellites and other, well, also deep space instruments are able to collect more data than they're able to get back to Earth. So there's a major bandwidth challenge there. And as a result, they have to, downsample or discard data. So we think that one of the ways that, access to Earth observation and deep space data is simply to embrace new technologies that allow us to expand bandwidth. New constellations are part of the solution, as are new technologies. So not a very concise answer, but that's generally how I see the problem.
Okay, thanks a lot. Okay, thank you. Okay, we've gone through all of you for three questions, and maybe we can take 1 minute just to answer one of the questions from the audience. I know we haven't got much time, but there is only one, and I think it makes sense. It's addressed to Space Mesh. So Henry, Space Mesh wouldn't adding the unavoidable frictions of a blockchain having to interact with a speculative token and having no operator make the network less efficient, viable, not more? Are you still muted, Henry?
Okay, yeah. So I think blockchain technology is very important for development of the LEO constellations, because blockchain technology is about consensus. So, and also it's have the billing functionality and distributed ledger inside. So, I mean, in the long run, for example, after 5 years or after 10 years, and the constellations need intercommunications and interconnected at that moment. And crypto, actually blockchain is the best way to get all constellations get connected. And even about like in the long run, for example, in the Mars, and when people make payment to communications. So that definitely at the very beginning will be mesh network. A mesh network for the spacecraft and the mesh network on the ground. And the payment will be made automatically with the crypto. It's not a fiat anymore. So that's why blockchain and combined with the LEO constellations and space technology is critical, I mean, for the next 10 years. And our founding father called the Liglider, and his name is used in one of the Liglider protocol. It's for the space technology. So I think it's not like happen to be there. That's destination. That's human connectivity destination. Okay, peer-to-peer and connections. Yeah.
Great, Henry. Thanks a lot. It's been great. We don't have more time for questions but it's been extremely interesting, at least on my side. And I thank you a lot for not maybe keeping the time, but giving very interesting answers. It's clear that there is a new ecosystem in front of us, and the possibilities and business models are multiple. So there is also, a new opportunity for investors, and I think we've summarized all these issues very well here today. So thank you very much for being here with us, and I hope the audience also enjoyed it as much as me. And we'll see you next time.
Okay, good. So good. So we are wrapping up the session. I thank all of you for your participation and assistance. I just wanted to take some takeaways that I think that are important for us, for all of us. Basically, we have heard about